this video, we are going to learn how to solve absolute values inequalities. But first, we have to look at the definition. Absolute of x less than a. It means that the distance of x from 0 is less than a. So, if we try to show it on number line, where we should put x. So, x should be put between negative a and a. So at one time, let's say, if we put x here, when we try to measure the distance from 0, the distance is less than a. So that's why x is greater than negative a and less than a. Or, in other way, we can write it down as x less than a and x greater than negative a. So, for the second one, if we have absolute value of x greater than a, on number line, absolute of x greater than a is the distance of x from 0 greater than a. So we should put x on the right side of a or on the left side of a. So let's say at one time when we put x here, when we measure the distance from the origin, the distance of x is greater than a. So that's why we write absolute of x greater than a as x greater than a or x less than negative a. So let's look at the example. The first example, we have absolute value of 3 minus 2x greater than or equal to 5. So here we have absolute value of x greater than a, meaning that we have x greater than a or x less than negative a. So first step is we open the absolute value sign. So 3 minus 2x greater or equal to 5 or 3 minus 2x less than or equal to negative 5. And then we solve these two linear inequalities. So on the left side, we have negative 2x greater or equal to 2. So we have to divide the inequality by negative 2. Don't forget to change the sign. So we have x less than or equal to negative 1. For the right side, we have negative 2x less than or equal to negative 8. So x greater or equal to 4. So remember here, we use the word or. Or means union. So for these two interval, we have to simplify it by using number line. So we have negative 1 and 4, x less than or equal to 1, and another one is x greater or equal to 4. You want to find the union, so you should shade all the interval. So the conclusion is from negative infinity to negative 1, union 4 to infinity. F absolute value of x minus 3 less than 3. So remember, absolute value of x less than a, it means x less than a and x greater than negative a. So here we have x minus 6 less than 3 and x minus 6 greater than negative 3. So x less than 9, x greater than 3. And here the word is and. And means intersection. This means for these two interval, we have to simplify by using number line. We have 3, 9, x greater than 3, x less than 9. Find the intersection. The intersection should be here. So the solution for the inequalities is from 3 to 9 open interval. So the third example is absolute value of x squared minus 48 greater than 5. Remember, absolute value of x followed by greater sign. The definition is x greater than a or x less than negative a. So here, when we define the inequality, it will become x squared minus 48 greater than 5 or x squared minus 48 less than negative 5. So remember, for quadratic inequalities, the first step that we have to do is make sure the right side 0. So here we have x squared minus 53 greater than 0. Second step is factorize. So we have x minus square root of 53, x plus square root of 53 greater than 0. The third step is use table of sign or graph to solve the inequality. So here I choose to use the graph. So we have y-axis and then we have x-axis. So here is negative square root of 53. On the right side should be square root of 53. Draw the graph. The graph is smiling. So here we want to choose greater than 0. Greater than 0, that means it is above the x-axis. So the solution is from negative infinity to negative square root of 53 union square root of 53 to infinity. Okay, for the second inequality, we have x squared minus 43 less than 0. Factorize, we have x minus square root of 43, x plus square root of 43 less than 0. Use graph to solve this quadratic inequality. So this is y-axis, this is x-axis, negative square root of 43, square root of 43, and draw, sketch the graph. Okay, we want to choose here the negative values or less than 0. Less than 0 meaning that it is below x-axis. So the solution for the second inequality is from negative square root of 43 to square root of 43. Okay. Now, we are going to simplify these two inequality. So here, the word is or. Or means, for these two solution, we are going to find the union. Okay, let's see how we are going to simplify this two interval. So by using number of line, okay, we have negative square root of 53, negative square root of 43, 0, square root of 43, square root of 53. Okay, for the first solution, we have from negative infinity to square root of negative 53. So, on the left side of square root of negative 53. For the second one, on the right side of square root of 53. For the second solution, we have from negative square root of 43 to square root of 43. Remember here, we want to find the union. Union means we are going to shade all the interval that exists. So that means here the solution is from negative infinity to negative square root of 53 union negative square root of 43 to square root of 43 union square root of 53 to infinity. For the first example, we have absolute value of x squared minus 6x plus 4 less than or equal to 4. So here we have absolute value followed by less than. So it means that x is less than a and x is greater than negative a. So we define the inequality. So we have minus 6x plus 4 less than or equal to 4 and x squared minus 6x plus 4 greater than or equal to negative 4. Remember, the first step to solve quadratic inequalities, right side must be 0. So we have x squared minus 6x less than or equal to 0. Second step is factorize. So here we have x minus 6 less than or equal to 0. You can use graph to solve the inequality. So 0 and 6 are the zeros, and then we draw the graph. So here we want to find less than or equal to 0. So that means below the x-axis. So the solution for the first inequality is from 0 to 6. For the second one, we have x squared minus 6x plus 8 greater or equal to 0. Then we have to factorize. So we have x minus 2, x minus 4 greater or equal to 0. Use graph to solve the inequality. So we have 2 and 4. So graph open upwards. So we want here the positive values greater than 0, meaning that it is above the x-axis. So the solution for the second interval, for the second inequalities is from negative infinity to 2 union 4 to infinity. So the word here is n. N means we are going to find the intersection between these two intervals. To find the intersection, we need to use number line. So this is our number line. We have 2, 4, and 6. So for the first interval, we have from 0 to 6. Close interval. For the second one, we have on the left side of 2, that is from negative infinity to 2, and on the right side of 4, that is means from 4 to infinity. So here we want to find the intersection. The intersection is here. So therefore, the solution for this is from 0 to 2 union 4 to 6. Okay, for the fifth example, we have absolute value of x plus 1 over x minus 2 greater or equal to 2. We have absolute of x greater than a, so the definition should be x greater than a or x less than negative a. So now we solve this inequality. So we have x plus 1 over x minus 2 greater or equal to 2, or x plus 1 over x minus 2 less than or equal to negative 2. So here we have rational inequality. So remember, in rational inequality, the first step, we have to make sure that the right side is 0. We cannot simply multiply both sides by x minus 2 because we don't know whether x minus 2 is positive or negative. So the first step should be x plus 1 over x minus 2 minus 2 greater or equal to 0. Make the left hand side into one fraction. So we have x plus 1 minus 2x plus 4 over x minus 2 greater or equal to 0. And then we have negative x plus 5 over x minus 2 greater or equal to 0. Okay, for the right side, we have x plus 1 over x minus 2 plus 2 less than or equal to 0. Make it into one fraction. So we have x plus 1 plus 2x minus 4 over x minus 2 less than or equal to 0. Simplify the numerator. We have 3x minus 3 over x minus 2 less than or equal to 0. Okay, for these two for these two rational inequality, we have to solve it by using table of sign. For one inequality, we should use one table of sign. So here, for the first one here, find all the zeros in the numerator and in the denominator. So the zeros are 2 and 5. List down all the expression in the numerator and also in the denominator. Okay, let's say I choose 1 to test the value whether it is positive or negative. So negative x plus 5 will make it 0, and negative x plus 5 is in the numerator, so we can take the value of 5 here. Okay, negative 1 plus 5 is 4. 4 is positive. So on the left side of 0 is positive, the other side should be negative. X minus 2 will make it 0. But remember, x minus 2 is in the denominator. So we cannot take the value of 2 here. So test the value. So we have 1 plus negative 2 is negative. So this is the 0. The other side should be positive. And then the conclusion is negative, positive, negative. Bring down all the circles. So here we want to find the positive values. Greater than 0 means positive. So this is the interval of the solution. So for the first inequality, the solution is from 2 to 5. Half open interval. Okay, same goes to the second rational inequality. First, we have to draw the number line and then find all the zeros. So the zeros here are 1 and 2. List down all the factors and then test the values. Let's say I choose 0 to test the value. So 3x minus 3, 1 will make it 0, and 3x minus 3 is in the numerator. So we can take the value of 1. So 0 minus 3 is negative, so the other side should be positive. X minus 2 will make it 0, but we cannot take the value of 2 because x minus 2 is in the denominator. So use 0 to test the value. 0 minus 2 is negative 2, so negative, negative, the other side should be positive. Positive, negative, positive. Bring down all the circle. And here for the conclusion, we want to take the negative value less than 0. So the conclusion for the second inequality is from 1 to 2. Okay, now we are going to combine these two interval. So remember, the word we use when we open the sign of absolute value is or. Or means union. So for these two interval, we are going to find the union. So to simplify the interval, you are going to use number line. So we have 1, 2, 5. So the first interval is from 2 to 5. Sorry, here the sign should be open from 2 to 5. For the second, we have from 1 to 2. So we are going to find the union. Union means we are going to shade all the interval. So remember here, the interval is disconnected at 2. So the final conclusion is so the solution is from 1 to 2 union 2 to 5. Okay, for the final example, we have absolute value of 1 over x minus 1 less than 3. Okay, we have absolute value of x less than a. Remember, the definition is x less than a and x greater than negative a. So now we open the sign of the absolute value. So we have 1 over x minus 1 less than 3 and 1 over x minus 1 greater than negative 3. So this is rational inequality. The first step is make sure the right side 0. So 1 over x minus 1 minus 3 less than 0. Then make it into one fraction. So we have 1 minus 3x plus 3 over x minus 1 less than 0. Simplify the numerator. So we have negative 3x plus 4 over x minus 1 less than 0. Do the same thing on the right side of the inequality. Okay, so we have here 1 over x minus 1 plus 3 greater than 0. So make it into one fraction. 1 plus 3x minus 3 over x minus 1 greater than 0. So we have 3x minus 2 over x minus 1 greater than 0. Okay. The third step is we are going to solve this inequality by using table of sign. Okay, remember here the word is and. At the end of the solution, we are going to find the intersection between the two intervals. Okay, now let's look at the solution for the first rational inequality. So, by using table, okay, first we have to find all the zeros. So the zeros are 4 over 3 and 1. So 1 is here, 4 over 3 is here. List down all the factors. So we have negative 3x plus 4, x minus 1. Negative 3x plus 4 is 4 over 3 will make it 0. Choose, let's say, the value of 0 here. So when we substitute into the expression, we have here positive. So on the left side is positive, the right side is negative. For the second one, x minus 1, 1 will make it 0. So 0 minus 1 is negative. So the right side should be positive. So negative, positive, negative. Here we want to find the negative value. So the answer is in this interval. So the solution for the first inequality is from negative infinity to 1 union 4 over 3 to infinity. Okay, for the second rational inequality, the zeros are 2 over 3 and 1. So 2 over 3 is here, 1 is here. List down all the expression in the numerator and in the denominator. Okay, 3x minus 2. 2 over 3 will make it 0. So, let's say I choose 0 here to test the value. So 0 minus 2 is negative, so the right side should be positive. X minus 1, 1 will make it 0. So 0 minus 1 is negative. So the right side should be positive. So we have positive, negative, positive. And here we want to find the positive value. So the solution for the second inequality is from negative infinity to 2 over 3 union 1 to infinity. So these two intervals, we are going to combine it by using intersection. So we are going to use number line to simplify it. So we have 2 over 3, 1 and 4 over 3. So we will draw the first solution here on the same line, on the same level. So here on the left side of 1 and on the right side of 4 over 3. That is for the first solution. For the second solution, we have to the left of 2 over 3 and to the right side of 1. So these two inequality, these two intervals, we are going to find the intersection. So the final solution is from negative infinity to 2 over 3 union from 4 over 3 to infinity.